we don't get distracted. Okay, so we are starting the class and let's look at what are the things that we wanted to talk. Okay, here comes Ifsha also. So Myra, once Ifsha is here, I would need your help for closing the door. Okay. Can everybody hear me okay? Can you guys see my finger dancing around the corner of the board? Yeah. Alright. So the topics that we are going to cover today are, we'll talk about polynomial identities and we'll talk about geometric series. Okay. So polynomial identities and geometric series. Now, a quick question to you all. What is your is everybody clear about polynomial? Sana, Jesse, Vaibhav, Anika, Bhavish, Lorania. So you guys remember what is polynomial, right? I don't have to go into that. Okay. Now, if somebody talks about polynomial identities, what do we mean by that? Hi, Disali.
Hi, sir.
And I always recommend kids to keep their videos on because when I see your expression, I would know whether I'm making sense or not. Okay? So, kids, and I call everybody kids, okay? So don't feel bad about it. My elder daughter is already in college, so I know what kid means to me. Okay? So Sana, Bava, Banika, Nanya, Dishali, all of you, if you can keep your video on, that will be a very comfortable setup so that others don't feel like odd one out. Okay? And you guys might want to say hello to each other. Okay. Alright. Cool. Anika and Sana. Okay, I will not insist anybody, it's just a recommendation based on your comfort. So we will talk about polynomial identities. What do we mean by polynomial identities? As Sangeeta, any idea? Okay, let me give you guys a very simple example. 4x squared plus 2x plus 7. This is a polynomial expression because you have 1, 2 and 3 terms. More than one term, polynomial. Yeah? Everybody with me so far? Everybody with me so far? Ifsha? I want you guys to pay attention to what we're doing, okay? I'm your superstar for next 1 hour. Focus on me, even if I'm not taking bath today. So, I'm just kidding.
Okay.
Alright, so coming back to this one, this is a polynomial. There are 3 terms and that's why they are called polynomials. Everybody agrees? Bhavish, Vaibhav, everybody? If I say this as 4x plus 2 plus 5x minus 9. This is also a form of a polynomial in the factorized form. Right? If I put an equal to here, that is what it means. Whenever somebody talks about polynomial identities, they are saying that there are 2 polynomials which are identical to each other. That's why this is referred as polynomial identity. Does that sound okay or not okay yet? Yeah? So, if you come across a question which says that x squared plus 6x plus 9 and x plus 3 whole squared, this represents a polynomial identity. What you will do is you will check whatever value you have on the left hand side and whatever value you have on the right hand side. If these two matches, then you will agree to that statement and say yes, these are polynomial identities. Does it sound reasonable to everybody? Yeah? Sana, Salvita, Anika? So all the kids whose face I'm not able to see, I will rely on your reaction. So either you unmute yourself and say yes, it makes sense, or if it doesn't, don't hesitate to say it doesn't. Okay? Now let's look. So here, from a topic point of view, there's nothing that I'm going to teach you guys with respect to polynomial identities. I was just telling you what polynomial identity means. Okay? Now we look at some problems and see if we are able to relate to it the way I described it. So let's look at some examples, some questions, and I would expect or assume full participation from everybody. Right or wrong answer doesn't matter. I need answer from you all when we deal with it. So let's look at the first problem that I have put here. The first question says, which of the equations are two identities? And here are the examples. This is one example which says x squared plus 2y times x squared minus 3y equal to x to the power 4 minus 6y squared. Option B is, second option is k cube minus r cube equals k squared plus r times k minus r squared. And I'm reading the question again. It says, which of the equations are two identities? So this is one equation where you are seeing polynomial on this side and polynomial on this side. This is the second equation where you are seeing this polynomial on the left hand side and this polynomial on the right hand side. The question says, which of the equations are two identities? And you have options like option A, option B, A and B both, none of them. Can you guys help me get the answer for this question? You have two equations given and says which of them are two identities. If these two are equal, then you will say yes, A is a true identity. If these two are equal, then you will say B is also a true identity. If that is not the case, you will challenge your teacher and say, give me more reasonable answers. How will you guys find it out? Hi Vasundhara. What is the first reaction from you guys? What are we supposed to do? Find it out. Are these identities? If these are identities, that means this value will be equal to this value. And that's what you have to find out. If this is an identity, then this value will be equal to this value. Then also you have to find it out. Ifsha, are you trying it out? Okay. Ananya, Jesse, Bhaiva, everybody tried, right? Sana, how about you, beta? Okay. Vasundhara, Sangeeta, everybody. Bhavish. B is the polynomial identity. Okay. How about A? You are discarding that option, Bhaiva? Okay. I don't know whether whatever you said is true or not. We'll see. So I got one answer. Bhaiva is saying these are two identity. I'm recording that as a response. I'm not confirming whether it's true or not. I don't know about A. Bhaiva is probably thinking that it is not. He's still validating it, right, Bhaiva? Okay. How about Bhavish? Try it. You got B. B you think is an identity, polynomial identity. How about the A? Yes, Ananya. You also got B. And you guys are saying that A is not an identity? Is that your statement? Jesse also thinks that way. How about Nishali? Yes.
I think it's A.
You think it's A?
I do think it's A.
You think it's A? A is an identity you're saying? Meaning this one and this one are same?
Yeah.
And B doesn't look like an identity to you guys? Okay. Alright.
I think A is one.
Okay. Yadisali.
I like it's B.
You think it's B? Okay. Now for the kid who is dealing with me for the first time, that is Jesse. So Jesse you'll be surprised to know that I have some bad traits. First trait is I don't trust anybody when it comes to math. So whatever you guys said, I'm just recording it without trusting it. The message for you all is, even if your best friend in the world says this is the answer, go for it, don't. Okay, I'm just passing it on to you all. Don't trust your best friend, your parents, your neighbor, whoever it is. Do it yourself. That's the best way to do it. That is one, okay? So you will learn all good or bad things from me. Everybody. Now, let me check. Is this a true identity or not? Meaning this side of the equal to sign will be equal to this one. If this is a true identity. Let's find out how much is this one. X square plus 2y times x square minus 3y. When we apply the distributive property, what it says, this will be equal to x square times x square minus 3y. This is x square. Plus 2y times x square minus 3y. So far no problem? So far looks okay? Now, let's break this bracket open. Sana, you did not tell me anything, beta. What is your response? Sana and Anika did not share their option.
I got B.
You also got B? Okay. So I'm anyways checking everybody. So, I mean, not checking everybody, I'm checking the right answer. So I'm solving both the options. First option I'm looking at x square plus 2y times x square minus 3y, and I just broke this open. So this, by using the distributive property, this means this times the whole thing plus this times the whole thing. Or if I want to break it the other way around, I'll say x square times this whole thing minus 3y times the whole thing. So anyways, I'm going with the option that I chose. It became x square times x square minus 3 x square y. This is done. Now I'm coming here. 2y times x square. So 2y x square. Plus into minus gives me a minus. 2 into 3 is 6. Y into y becomes y square. What do I have here? X square into x square is x to the power 4. Minus 3x square y. So minus 3x square y. See, x square y, x square y. These two terms are like terms. So if x square y is an apple, I have 3 apple here and 2 apple here. Negative 3 apple here, positive 2 apple here. That will become minus x square y. Minus 6y square. So, good that I did not trust anybody. This whole thing equals x to the power 4 minus x square y minus 6y square. That is nowhere same as this. Option A is totally out of equation. Okay? Does everybody feel comfortable with whatever I said or whatever I did? Okay, Sanvita, Vasundhara, you both okay? So option A is ruled out. I'm not leaning on that anymore. And what was the trick for finding it out? Trust me, there is no trick. There is nothing better than doing it. Now let's go to the second one. K cube minus r cube equals k square plus r, k minus r square. So what we, here I have two terms, so let me multiply these two things. I mean, this is clear, right? So let's break this open. Again, this is k square plus r times k minus r square. So you guys are convinced about option A not being a true identity, right? Okay, now here, same thing, distributive property. I'm not doing anything magical, anything different. This will be equal to, this multiplied by the whole thing plus r multiplied by the whole thing. So this becomes k square times k minus r square plus r times k minus r square. When I do k, now let's break this bracket open. K square into k will become k to the power 3. K square into r square. And here I have a minus sign, so this becomes minus k square r square. This one is done. Now I'm coming here. R into k is kr. R into r square. And I have a minus sign here, so this becomes plus into minus is minus. R into r square is r to the power 3. What do I have here? k to the power 3 minus k square r square plus kr minus r3. There is no like term here. There is nothing that I can do, right? K square r square, kr. No relationship. They are different terms. There is no linkage. So I will treat this as a different term, treat this as a different term. So when I expanded this thing, I got this, which is by no means equal to this. So now you guys see merit in the statement I made. I don't trust anybody. I'm not happy that you all went wrong. I'm just conveying the message to you guys that when it comes to math, it's a very simple thing that you have to solve. You know what I'm trying to convey? Why did you not solve it?
I did solve.
You solved it, but then you did not get the right answer. That means there was something that you missed. So it comes with practice. Let's see again. I'm not trying to put anybody on the spot here. My only goal is to navigate you guys the right direction. Okay? And here, when I was doing this problem, I did not impose any artificial intelligence. There was no AI, no machine learning. It was only human effort that you saw to validate this. Okay? Alright, my speech is over. Let's go to the next problem. Jesse, is it making sense to you better so far?
Yeah, it's making sense to me.
Yeah. So, see, all the other kids, they have dealt with me for some time. They know my good or bad jokes. But for you, it's the first experience. That's why I will keep on calling your name more often. But that is not to put you on the spot. It is only with the intent to make sure that the new child in the class is with me as well. Yeah? Alright. Here's the next question. This time I would expect a better performance from everybody. Though I will still stay with my statement of not trusting anybody. Y plus 6 times y minus 7 plus 42 equals y square minus y. This is the first equation. Second equation is x plus 3 times x minus 8 equals x to the power x square minus 5x. So same thing, it says which of the equations are true identities. So you have, this is option 1, y plus 6 times y minus 7 plus 42 equals y square minus y. And second equation is x plus 3 times x minus 8 equals x square minus 5x. This is your A, this is your B. You have to tell me which of these are true identities. Beat A, beat B, beat both of them, beat none of them. These are 4 options you have to choose from. And there is no magical answer for this. Do it. Vasundhara, Sanvita, Anika, Bhavish, everybody with me, right? Go for it. Ananya got scared of me, said, okay, I'll take my hand. I'm with you, don't worry about it. I'm okay. No, nobody gets scared of me, unfortunately. So I cannot brag about me being scary here. Y plus 6 times y minus 7 plus 42 equals y square minus y. Yeah? Yep.
I love B.
You think only B is the true identity? Not A? Okay, Bhavish, what did you get, beta?
I got B.
You also think it's only B as a true identity, not A?
Yeah.
Okay. And I will sound mean whenever I say I don't trust anybody, but that is only to convey one message that do it yourself. Yes, Sanvita. You got none of them as true identity? Interesting. Sana, tell me better.
I got none of them too.
You also got none of them. So Sana and Sanvita, you also got none. So Vaibhav, Sana and Sanvita are on the same line, on the same page. How about Dishali?
I got the same 1 to 0.
Same as whom?
Sanjita, definitely.
Okay. So Sanvita and Sana and Vaibhav, you are saying also thinking that it's none. Okay. Yep.
I also got no identities.
What did you repeat?
I also got no identities.
None of them are identities. Okay.
I want to change my answer to no identities. Like both of them.
Both of them are not identities. Okay.
I got A.
You also got A. Okay. So you think A is a true identity.
I think so, yeah.
Okay. Okay. Anyways, see. Good thing is, even if the answer is wrong, there will not be any crackling sound coming from the roof. Okay. The sky doesn't fall. We're just doing it. We will figure out where we are making mistake by doing in a hurry, where somebody else is making mistake or picking a different approach. Okay. How about you, Peter?
I got none.
You also got none. So many of the kids are saying none. Some of you are saying A. Some of you are probably saying B. But I will again use the same simple approach. Let's go to the first one. A. If this is my left hand side of the equation. Let's find out how much is that. Y plus 6 times y minus 7. Y plus 6 times y minus 7. Plus 42. This is what we have on the left hand side. Let's break it open. So y plus 6 times y minus 7. So that means y times y minus 7 plus 6 times y minus 7. So this is the breakdown of this using the distributive property. Now I have 42 here. Now when I break this bracket open, this becomes y to y square minus y to 7. So minus, I have minus here, so it's minus 7 to y is 7y plus 6 into y is 6y plus into minus gives me a minus 6 7 is 42 plus 42. So what's happening is these two guys are getting cancelled out, 42 and minus 42. And here this becomes y square, and these two are like terms. Here is 7y, 6y. If this is watermelon, I have 7 watermelon and 6 watermelon here. So this became y square minus y. So minus 7y plus 6y gives me a minus y. Is this value same as this? Answer is yes. So A is certainly a true identity. Okay. Now, again, nobody should feel disappointed about it. It's just simple calculation. All that will come with practice. So don't even think, oh no, how come I could miss this? Nothing goes wrong. My sky, the sky has never fallen. Otherwise, I would have been teaching you guys without a roof. Correct? So sky doesn't fall. Don't worry about it. Now second one. So this one looks like a true identity. Now I'm coming to the second one. X plus 3 times x minus 7. So what we'll do is we'll expand this and see how much it is. Is it matching with this or not? So x plus 3 times x minus 8. And some of you must be getting bored because I'm doing the same repetitive old stuff. It's okay. Math is about practice. We end up doing the same thing. So when I break this open, it will become x times this whole thing plus 3 times this whole thing. So x times x minus 8 plus 3 times x minus 8. Now, let's break this bracket open. It becomes x times x is x squared. X times minus 8. So, minus into plus is minus 8x. This is done. I'm coming here. 3 times x is 3x. And 3 times minus 8 will give me minus 24. Now, when I look at this, only these two are like terms. So it will become minus 8x plus 3x will give me a minus 5x. So this is x squared minus 5x minus 24. So this one is giving me this value, and my right hand side is x square minus 5x. This 24 is missing, so this is certainly not a true identity. So only A was the right identity. Whatever I did, does that sound convincing to everybody, or anybody wants to contest? Are you guys comfortable with whatever I explained? So okay, guys, calm down. Here, okay. You need water or something? Okay, no? Okay. So, okay, make sure that we are holding our horses, because horses are wild, they go everywhere. We need to tame them so that they stay in the class. Here, come back to this class. Okay, no, please. Here we had two equations. We did nothing fancy about it. We just found the value of this by breaking the brackets open. We found the value of this by breaking the brackets open and compared that with the right hand side of it. Okay. And we found that this is a true identity, this one is not. That's it. So far okay? So, summary of this is, I'm not going to drag this discussion further by talking more about polynomial identities. Polynomial identities in simplest form that we want to understand is, it simply refers to an equation where your left hand side and right hand side of the equation matches. If it does, these are called true identities or polynomial identities. If they don't, you will discard it for being called out as polynomial identity. Is that okay? Now, we'll go on to the next topic, which might be a little more interesting than what we have been doing so far. And that is about geometric series and sequence. So, Mara Nariari, control. I'm hearing a lot of sound. Okay, so we are going to talk about geometric series and sequence. First of all, what do we know about a geometric series or a sequence? Geometric sequence. Let's start with geometric sequence. What do you know about it? Yeah.
It's like shapes.
Geometric sequence. I'm talking about sequence.
Oh no.
Okay. How about you, Peter? Have you heard about it?
I have heard about it, but I forgot.
Okay, that's okay. Anybody on the screen? Have you guys heard about what is a geometric sequence?
So I think geometric sequence is a list of numbers where each term is like a product of the previous term or common ratio of the previous term.
Okay. Yeah, so Vaibhav told the golden words and disconnected. He got kicked out from the meeting, but anyways, he was gone back. But yeah, he was heading us in the right direction. So let me give you guys an example. When you talk about, so now the next thing that Jesse will hear today is another concept that I keep forcing on you guys is math as a language. If math was an identity, a character, a personality, math's mother is English. Okay. Meaning, if you come across any mathematical term, before you get into the mathematical complexities of it, as long as you know what is the meaning of it, if you derive the meaning of the term first, then you'll be able to relate to it mathematically. Okay. So, Vaibhav, you are going the right direction. Okay. And I'm very happy that I could hear you. I'll tell you why. Because it's the same machine, laptop that Yaganya uses, and she was not able to speak up in the classes for last couple of weeks. So I'm pretty sure that hereafter she will be able to speak up as well, because there was something wrong with the mic, I believe. Okay, anyways, coming back to this one. So geometric, this marker has come to the end of life. Sequence. So there are two things. One is sequence. and then geometric. We'll come to this geometric word later. When you talk about sequence, you're talking about certain pattern. If I give you 6 numbers here versus 1, 3, 19, 8, 15. If you look at this series of numbers, there's some sequence, some pattern that you see here. 1, 2, 3, 4. It's increasing in a certain way, in a predictable way. If somebody says what will be the 7th number, you will say okay, everything is increasing by 1, so the next number will be 7. Yeah. Here when you see, you have the same number of numbers, 5 numbers here also. I mean, here you have 6, here you have 5. But there's no pattern. It doesn't give you that predictability. You cannot predict if these numbers, these 5 numbers are given to me, what will be my 6th number? Will it be 7? Will it be 27? Will it be 5,000? Will it be 2 million? We don't know. So, whenever you talk about sequence, you are essentially talking about a pattern. How you can predict, what is the correlation between you see between 2 consecutive numbers. Okay? So, sequence is always something which is predictable in nature. Everybody with me? Alright. So, second part of the term is decoded. We know sequence is nothing but a series of numbers where there is some predictability, some relationship between 2 consecutive numbers. Geometric. Geometric sequence. So there are 3 types of sequence that we will come across. Not today, but in our journey at some point in time. One is called arithmetic sequence. Second one is called geometric sequence that you already heard about. And third is called harmonic sequence. Okay? When you are, your numbers, let's say 1, 3, 5, 6, 5, 7, 9. I have just put few numbers here, trying to depict some sequence. 1 to 3, there is a difference of 2. 3 to 5, there is a difference of 2. 5 to 7, difference of 2. 7 to 9, difference of 2. So if I ask you to find out the next term in the sequence, you will say it will be 2 more than 9. Okay? If I ask you to find a number before this, you will say 1 minus 2, which will be minus 1. Yeah? So far, sounding okay to everybody? Ananya, Vasundhara, Sanvita, Sana, everybody okay? Okay. So, this is arithmetic sequence where when you, by doing some basic arithmetic equation, operations, adding or subtracting, okay? When you are adding or subtracting any number to a number and then you get your consecutive number, I mean the subsequent number, that is arithmetic sequence. Now you look at another example where you have 1, 4, 16, 64, 256, only that much I remember manually. 256 times 4 I don't remember exactly. I think that is 1028. Yeah. Okay, I'm good till this. Okay. When you are looking at this sequence, again there is some predictability. And that predictability is 1 times 4 is 4. 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 256. Times 4 is 1028. Yeah? So here, the next number can be achieved by multiplying 4 with the previous number. And that is what Vaibhav was trying to explain. The geometric sequence is something. Yep.
Can I go inside and get water?
Yeah. Geometric sequence is a sequence of numbers where you can get the next number by multiplying or dividing previous number with something. Okay. So it's not only about multiplying. You might have a sequence which is written in the reverse order. 1028, 256, 64, 16, 4, 1. This is also geometric sequence because you are getting the next number by dividing the previous number by 4. Okay. So now I'm breaking it down. When you are getting the next sequence, next number of your sequence by adding or subtracting, that is called arithmetic sequence. When you are getting the next number of the sequence by multiplying or dividing by a common term, that is geometric sequence. Now you guys will ask me why it is called geometric. Because here you are adding, subtracting, that is arithmetic operation. Here you are multiplying or dividing, that is also arithmetic operation only. So they are kept separate. Probably when I was your age, I had convinced myself with this argument. Because when you talk about geometry, let's say if you're talking about area of a triangle, what you're doing is half into base into height. Talking about area of rectangle, length times width. Talking about area of square, you're talking about length into length. So you're always multiplying. When you're dealing with geometry, finding out the area, you're always multiplying. So that is how I convince that, okay, fine. Whenever I'm talking about next term being obtained from in the sequence by multiplying or dividing, I will call it geometric sequence. When I'm getting next term by adding or subtracting a number, I will call it arithmetic sequence. If that statement sounds okay, you can use that as a way for convincing yourself for recalling this one. If it doesn't, you can find out more creative ways. Okay? But this is a very, very high level view of what is what is a geometric sequence. Is everybody okay so far? Yeah? Ananya, Anika, Vishali, Bhavish, everybody okay? Sana okay? Now, we were just touching the tip of the iceberg. Now we are taking a dip. Okay, let's go deeper into it a little bit. So essentially what we are saying is a geometric sequence, I will use acronyms, geometric sequence, that's what I'm calling it. Okay. Here, let's say 1, 3, 9, 27, 81, 243. I'll leave it there. Is this a geometric sequence or an arithmetic sequence based on whatever we have discussed so far? Is it geometric sequence or arithmetic sequence? What do you guys think?
Geometric.
Geometric? Why?
Because it has to do something with
Multiplication, right? You're multiplying 1 by 3, you're getting 3. Multiplying 3 by 3, you're getting 9. Multiplying 9 by 3, you're getting 27, 81, right? So this is geometric sequence. Authentic, legible, not legitimate geometric sequence. Yeah, everybody agrees? And you are seeing that you multiply by 3, multiply by 3, multiplied by 3, multiplied by 3, multiplied by 3. So if you have to find out the next term, you will multiply by 3 and you will find it out. Right? This is a geometric sequence. What you saw was, this was the multiplication factor which helped you get the next number. Correct? What is that called? Vaibhav? Common ratio? Common factor? What is that called?
Common ratio.
Common ratio. So this is a common ratio. Okay? This is a term used, common ratio. So now let's look at it. Whenever you're talking about a sequence, it always has a starting point. Okay? Yes, sequence starting from 1 here in this case. So when you're starting any sequence, you always have a starting point that helps you navigate further. So first thing is starting point. Let's give it a name A, right? Alphabets start from A, so we'll give A. And then this is common ratio. So starting point or first term, whatever you call it. Let's say A. and common ratio, we will give it a acronym as R, ratio, first letter of ratio. So now we have A and R. In this case, what is my A? 1. What is my common ratio? R, 3, correct? Now, let's visualize this in a very generic form. So my A was 1 and R was 3 here in this sequence. Everybody is with me so far? Let's write in a more generic form. So this was A times R. This term became A times R times R. This term became A times R times R times R. Are you guys seeing something here? With every term we are multiplying by R and it's increasing. I had only put 6 terms here. Not 6 terms, 6 numbers. Okay? With every number, every subsequent number you are multiplying by R. And the number of R's in your number is increasing. Correct? Is it making sense or I'm making it complicated so far? Vasundhara, Sanvita, Anika, everybody okay? Nanya, Lisani, everybody okay? So, we had the sequence. We said, okay, I will term the first term as A and the common ratio as R, and then we are trying to generalize this. Now, I have only put 6 numbers here. Can you guys tell me what will be the 200th number of this sequence? 200. So this is the first number, second number, third number, fourth number, fifth number, sixth number. Can you guys tell me what will be the 200th number of this sequence? Everybody is scratching head. That is exactly what I did when I was your age, and that is how this is the end result. Lost hair. Don't worry about it. Alright, so jokes apart, coming back here. What you are seeing here is first term has no R. Second term has 2 minus 1 R. Third term has 3 minus 1, 2 R's multiplied by each other. Fourth term has 4 minus 1, 3 R's. So whichever number you are coming to that has as many R's, one less than the number of the term. Again, look at it. First term has no R. So 1 minus 0 R. R to the power is 1 minus 0. That's what it is. Second term has 2 minus 1. This is the power to the R. Third term, if you see R, okay, let me write it down. So this is AR square, AR cube, and then AR to the power 4, and it will continue, right? Because every term you are multiplying by R. So what you are seeing is first term has 0 R, second term has 2 minus 1, that many R's. Third term has 3 minus 1, 2 R's, or R to the power 2. Fourth term has 4 minus 1, that many power to the R. So if I am talking about nth term, let's assume hypothetically n is any number. It could be 200, could be 2000, could be 5000. Then the nth term in this sequence will be A R to the power n minus 1. I'll give you guys some time to digest this. Bhavish, is it making sense, beta? Yeah? Vishali, okay? Sanvita, Vasundhara, Vaibhav, everybody okay? Sana, are you able to relate as well, beta? Ipsha, Aryahi, Maira, yeah? So, what we saw was, okay, let's teach the story again from the beginning. Geometric sequence is nothing but where any two consecutive terms in the sequence are related by a common ratio. Okay? Any two consecutive terms. I'm not talking about this one and this one. There's a gap. Any two consecutive term is related by the same ratio, that is called common ratio. So, if you have any sequence, if you give the name as A to that, second term will be AR, third term will be AR into R, AR into R into R, AR into R into R into R, and that story goes on. So we just wrote that in the short form, like power. And from that we are trying to derive the interpretation that, okay, if I'm talking about nth term, first term has one less R, second term has one less R again, third term has one less R, meaning one less from the nth term we are talking about. So nth term will be AR to the power n minus 1. That will be my nth term. So the question I was asking you guys was, okay, can you find out the 200th number in this one? 200th term. So in place of n, I'll put 200. So that will be my first term is 1, A, R is 3, common ratio, to the power 200 minus 1, which is 1 into 3 to the power 199. If you can calculate that, that will be the value of the 200 term in the sequence. Does it sound okay? No, not okay. Everybody's getting stressed out. Okay, so now let me show you guys a quick example, and then we'll talk about geometric series. So let's say if I have a geometric sequence given as 2, 4, 8, 16. Okay, only 4 terms are given. What is the value of A here in this case? If we try to relate it with the first, A is my first term. What is the value of my A? 2. Right in front of your eyes. This is A. This is the first term. What is the common ratio in this case?
Multiply by 2.
My question is simple, point blank. What is the common ratio here in this case?
2.
2. That is what I was looking for. Okay. So we know if we have this, my A is 2, my R is also 2. Okay. Common ratio. Every term is obtained by multiplying the previous number by 2. Everybody with me so far? If the question says, find out the 20th term of this sequence, you will say, we know the nth term, let's call it Tn. Nth term is A times R to the power n minus 1. That's what, guys here. 20th term, this is AR square, AR cube, and we know that nth term of any sequence will be the A times R to the power, which term we are talking about, that minus 1. So if you try relating this formula that we just derived, if I want to find out the first term, I'll put 1 in place of n. So my A is 2 and R is 2 and 2 to the power, we are talking about first term, which is 1, n is 1, minus 1, sorry. So this became 2 into 2 to the power 0. 2 to the power 0 is 1, so 2 into 1. This is my first term as well. Okay, applying the same formula. Somebody says find out the second term. Second term would be T2, second term. So my n value is 2 here. My A is 2, my R is also 2, my n is 2, n minus 1. A R to the power n minus 1. That is how you find the nth term. So we are trying to find the second term and we want to see if this is matching with this guy or not. 2 into 2 to the power 2 minus 1, which is 1. 4, matching. Now we are talking about finding out the 15th, let's say 10th term. 10th term, same thing. My n will be equal to 10. We are trying to find out the nth term. So T10, which will be A times R to the power n minus 1. This is my formula. Here my A is 2, my R is 2, and n is 10 because we are trying to find out the 10th term, 10 minus 1. So this will be 2 into 2 to the power 10 minus 1, that is 9. Find it out. This is just to relate how you find out the nth term of a given sequence. Okay? For a geometric series. Geometric sequence. So this is just the starting point. Now, if you talk about the other term that will come across, that is called geometric series. You know what is different between geometric sequence and series? I spent literally 1 week of confusion for myself when I was your age because I was struggling. I see a series of numbers, they are calling it geometric sequence. What is geometric series then? Yes, Babu.
Is there like a group of geometrical sequences and like compare it?
Babu.
Geometry series is like among terms of geometry sequence.
Okay, so here's the thing. Sequence and series. This is very, very math specific. If you are talking about geometric sequence and geometric series, geometric sequence is A, your first term, AR square, AR cube, AR to the power 4, and it just goes on. This is your sequence, which depicts what are the terms, what is the relationship, how is the pattern working. This is called geometric sequence. Okay? Geometric series is actually a sum of all your terms. Somebody will say, okay, find out the geometric series of first 20 terms of a geometric sequence. Meaning, all the terms you have, all 20 terms that they're talking about, you add them up. Okay? So if I want to torture you guys, I will say, I have a geometric series, geometric sequence 3, 6, 18, 20, 54, 162. Okay? Find out the geometric series for first 60 terms. First 60 terms. Meaning, here is your sequence, you know what is the relationship, everything is getting multiplied by 3. This is your first term. Sum up first 60 terms. So what you will do is, first derive all 60 terms. Yeah.
If everything is being multiplied by 3, shouldn't the first number be 2?
No, this is 3.
No, 3 times 3 is 1.
Oh, okay. Yeah, okay. Yeah, that was a good catch. So this is, okay. So, every term is multiplied by 3. So, I'm asking you guys to sum up first 60 terms of the sequence. Difficult task. It will take maybe 1 hour, 45 minutes. Yeah? And I certainly don't want you guys to do that. There is a way you can find out the formula for geometric series. So again, just to be clear about it, when you're talking about number of terms and the relationship among them, this is called geometric sequence, which represents a set of numbers that you're dealing with. Geometric series represents sum of all the terms. They might say, find out geometric series for first 5 terms of the sequence. Find out geometric series of first 20 terms of the sequence. Okay? And the formula for that is sum of n terms is equal to a into 1 minus r to the power n divided by 1 minus a. By 1 minus r, my bad. And this is one thing that I hate. I don't like memorizing formulas. So in the class, I always tend to derive the formula for you guys so that it becomes more convincing. I might go wrong when I have to, when I derive it and I realize that okay, this is not the right formula. So we'll check on that, okay? This says sum of n terms. Let's say if somebody says find out sum of first 5 terms. So n is 5. So and the first term is, let's say 2. 2 into 1 minus whatever is your common ratio. 2 into 1 minus the common ratio to the power 5. You'll replace that by 5 and do this. Now let's look at how do you derive this formula itself. Why this formula to be believed? Do you guys have enough energy to deal with me for another 5-6 minutes? Yeah? 5 minutes? We'll just look at this formula. Are you guys okay? So, geometric series says, I'll use that the more generic way. Geometric series is nothing but we are trying to find out a plus ar squared plus till the nth term ar to the power n minus 1. Okay? This is what we are trying to find out. When we are able to sum them up, that will be my end goal. Okay? Now, what I want to do is, I want to multiply this whole thing by r. Okay? When I do that, this will become ar, this will become ar squared, this will become ar cubed, so on and so forth. Yeah? So I want to multiply it by minus r, let's say, and shift everything by one place. So when I multiply this whole thing by minus r, it becomes minus ar, and I will put it here. When I multiply second term with this, it becomes minus ar squared, minus ar cubed, and then minus ar to the power n minus 1. And then the last term, this one, when I'm multiplying that by r, it increases the power ar to the power n. I had all these terms. What I did was I multiplied the whole this thing by minus r, and while writing it down I shifted everything by one place. Okay? And the reason why I did that is this. Now if I try adding these two equations, what will happen? Sn minus r into Sn will be equal to a. This is getting cancelled out, this is getting cancelled out, everything will get cancelled out, even this one is getting cancelled out. What I am left with is minus ar to the power n. Now you guys see a reason why I multiplied by minus r, and while writing I shifted it by one place. Is it sounding okay or making you guys scratch your head as well? Yes. Yes. Okay, that's okay. But is it making sense to everybody? We are almost done, okay? Just bear with me for one more minute. It will be fine. So, we were trying to find out sum of all the terms, which is geometric series. And we just wrote the number in the generic, all the terms in generic form. And then we multiplied each and every element of that with a minus r. And while writing it down, we shifted it by one place. And then when we add these two equations, we got this. Sn is nothing but the sum of all the geometric terms or by geometric series. Okay. So here Sn is common, it becomes 1 minus r. And here you see a is common, it becomes 1 minus r to the power n. So what we were trying to find out was sum of all the terms. So that means I will just move this guy to the other side, and it becomes 1 minus r to the power n divided by 1 minus r. When this guy comes this side, it becomes denominator. So this is the formula I was talking about. That if you have to find out the sum of n terms or first n terms of a geometric sequence, or if you have to find out the geometric series of this, we just derive the formula for ourselves. Is it sounding? reasonably digestible, trustable, relatable, then that is the ride for today. It's over. Okay? I will let you guys go. Enjoy the rest of your evening. And I'll upload the video of the class. Just watch it afterwards to be able to relate to it. Okay? Because I talked a lot. I may or may not have made sense for some part of the class. So when you watch the video, you'll be able to relate to it. Alright? Have fun. We'll do more practice. I'll send some assignments and then talk to you guys soon. Yeah? Bye-bye. 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 Bye-bye.